Number 1, the table below shows the cost of a pizza based on the number of toppings. Which function represents the cost of the pizza in? So I want to remind you about the Dino or Dino method. Remember we talked about the DI stands for the difference. And then we have the N, which is going to stand for the variable. And then finally, we're going to have the 0. So that 0 is going to stand for the value at 0 terms. So we would work backwards. So when I look at this example, the first thing that I see is between each one, I see that we do have a common difference of $1.50. So every time we're adding $1.50. So when I write my equation, I have y equals, and we're going to have $1.50 x. The reason I put x is because I'm just using x's and y's right now, but that's what the n stands for. And then we need the 0 term. So the 0 term is actually working backwards. So if I'm at 1 and I want to go back to 0, I need to subtract 150. So if I'm at 12 and I subtract 150, that's going to give me a total of 1050. So this is going to be plus 1050. Now if I look at my answer choices, I don't see that answer choice there. I do see that I have a slope of 150, but they put the y-intercept as 12, but it's still not going to be B. It's not going to be C, and it's not going to be D. So why is the answer A? So if we simplify this, this is going to turn into 12 plus 150n minus 150, which is basically what we did. We subtracted 150 from 12. So there's my simplified version, which the answer would be A. All right, number 2. I have this sequence. So the sequence below shows the total number of days Francisco had used his gym membership at the end of weeks 1, 2, 3, and 4. So assuming the pattern continues, which function would be used to find the total? So again, I'm going to use that Dino method. So we're going to start with the common difference. So the common difference is adding 5 each time. All right, so we have y equals 5. Or the n is your variable, or x, either one you choose to use. And then we have the 0 term. So if I work backwards, so this is term number 1, this is term number 2. So we need to find term 0. So if we work backwards and we subtract 5, that's going to give me negative 1. All right, so then we have what we talk about as far as a recursive formula. Now remember, a recursive formula means that I'm going to have to know the previous in order to get to the next. So this is saying that my first term is equal to 5. Now, if you remember, n minus 1 represents the previous term. So this is saying 3 times the previous term. And they want us to get to the 4th term. So we have the first term we know is 5. So the second term is going to be 3 times the previous. Well, 3 times the previous is 5. So 3 times 5 is 15. Then the third term is going to be 3 times the previous, which is 15. That's going to be 45. And then the 4th term is going to be 3 times 45, which is going to be 135. So the answer is B. Number 4, for this arithmetic sequence, so again, this is a recursive formula. Remember, recursive, we need to know the previous in order to get to the next. So my first term is negative 8, and that n minus 1 is my previous term. So they want us to get to the 7th term. So we're going to start. We have the first term. We know that's negative 8. Then for the second term, we're going to do the previous. So our previous term is negative 8 plus 4. That's going to give me negative 4. Then the third term is going to be negative 4, which is the previous, plus 4. That's 0. Then the 4th term is going to be the previous, 0 plus 4, which is 4. 5th term, the previous, which is 4, plus 4 again, equals 8. Then we have the sixth term is going to be the previous, which is 8 plus 4. That's 12. And then we have the seventh term. The previous is 12 plus 4, which is 16. All right, Leonard wrote the sequence below. So remember, when we're doing a sequence, this is the first term, second term, third term, and fourth term. They want us to write an expression, so we're going to use that Dino method, however you want to pronounce it. So the common difference, so what's happening each time? So each time we are going to be adding 6. So we know the common difference is going to be 6. So then we're going to bring down the n or the x, whichever variable you choose to use. And then we need the initial term. So to find the initial term, we're going to work backwards. If I'm at 9, I'm going to go backwards by subtracting 6, which is going to give me 3. So recursive formula below, which one describes the following sequence? So our first term is -3. All right, so if we have -3, how do we get from -3 to 1? So -3 to 1 would be adding 4. And then the second term would be 1. So 1 plus 4, that would give me 5. So we're adding 4 each time. So the one that shows me adding 4 to the previous term is D. And she asked her student, Miss Morris gave her students this pattern of white tiles. She asked her students to write an equation that represents the tiles for any figure. So the white tiles is what we're looking for. So in the first figure, we have a total of 1, 2, 3, 4, 5, 6, 7, 8. 8 tiles. Then in the second one, we have 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, and the next one we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then in the last we have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So again, using our method, my common difference is adding 4 each time. Okay, so 4. We're going to bring down that variable n, or if you want to use x, it's completely up to you. And then we need to find our initial term. So our initial term is going backwards. So instead of adding 4, I'm going to subtract 4. And that's going to give me 4. For number 8, this shows a pattern. So we have a set of sequences that's going on with these circles. And it says which function can be used to determine the number of circles in the nth figure of the thing. So if I make a table of values, so for my first term has 3 circles. My second term has 6 circles. My third term has 2, 4, 6, 8, 10, 12 circles. And my fourth term has 4 times 6, which is 24. So what's happening every time? So every time I'm multiplying by 2. So this isn't actually going to be an arithmetic sequence. This is going to be a geometric sequence. So this geometric sequence tells me that I need to multiply every time. So this is actually going to be exponential. Now, in order to look at this problem, I have to start, I can't start with the 0 term. I cannot work backwards and find the 0 term because we'd have to divide by 3, or divide 3 by 2 and get 3 over 2. Well, we don't want that. So instead of starting with the 0 term, we're actually going to start with the previous term, okay? So we're going to do that n minus 1 to get the previous term. So what I want is my initial term this time is going to be my 3. So y, remember, exponential is y equals a times b raised to x. But this time we're going to do a times b raised to x minus 1 because we're going to do the previous term. So my a value is my 3. So my a becomes 3. My b is what I'm multiplying by, which is going to be 2. So therefore my answer is going to be n minus 1, making the a. So my answer 9. It says the vertices of a rectangle are located at these points. What is the area of that rectangle? So I'm actually going to insert some graph paper because you will have graph paper to use on your exam. So when I'm looking back, my first, so I have 1, 2. All right, so if you're actually using the written graph paper, you're going to want to draw your coordinate plane. All right, so the first point that we had was at 1, 2. All right, there's my first point. All right, then we have 5, 0. Then we have 2, negative 6. And then finally we have negative 2, negative 4. Now the problem asked me for the area. So remember, to find the area, we need to do length times width, because we have this rectangle. So we need to find the length of the length, and we need to find the distance of the width. So if you remember when we talked about this in terms of Pythagorean theorem. So to do the Pythagorean theorem, you're going to make a right triangle that connects to the side you want to find. So this is a distance of 2, and this side is a distance of 4. And actually, so you're going to make that right triangle, and you're going to find the distance of the horizontal and vertical line. So this is 2 and 4. So I'm going to do my Pythagorean theorem, and so this is going to be 2 squared plus 4 squared equals c squared. So we have 2 squared is 4 plus 16 equals c squared. So we have 20 equals c squared. Now we do not want to leave that as 20, because we're going to have to take the square root of that value. So when we go to take the square root, we're going to round our decimal, and we're going to get when I did the square root, I got c is approximately 4.47. Okay, so now we're going to do the same thing, but we're going to do it to the other side that we want to find. So we have 3 and 1, 2, 3, 4, 5, 6. So 3 squared plus 6 squared equals c squared. So we have 9 plus 36. So that's going to give me 45 equals c squared. And we're going to take the square root of that to get the c by itself. So if I do the square root of 45, I got 6.71. Now remember again, to find the area, we want the length times the width. So we're going to do 4.47 times the 6.76. So 4.47 times 6.7. And I got approximately 29.99. So if I go back to my answer choices, 29.99, that's going to round me to 30. Now, the other thing is, if you're obviously going to have a calculator to do the square root. So just remember the square root, so we did the square root of 45, is in the keyboard. So you can easily put that in Desmos when you're using your calculator. All right, so for number 10, it says that R is the midpoint of the segment PS. Q is the midpoint of the segment RS. So P is located at 8, 10, and S is located at 12, negative 6. They want to know where is Q located, okay? So again, I'm going to insert some graph paper here, and I'm going to graph this. I think it's going to be easier to see. And then we'll kind of look at it in Desmos as well. So I'm going to draw my lines here, just like you can draw your lines. You can have as much graph paper as you want. And we need 12, negative 6. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, and negative 6. All right. So it told us in this problem that we have P and S, so this is P, this is S, and it said that Q is the midpoint of R and S. So we have R, okay, so R is at the midpoint, and then Q is at the midpoint of that. So like if I have this graph here, so I kind of have this graph, so if I kind of estimate the middle, so we're going to do this we're not even going to do a formula for this one, we're going to kind of estimate here. So if I estimate the middle, we're looking somewhere around here for R. So we'll say this is R. And then once I estimate the middle of that, we're looking at somewhere in this direction. That would be Q. So which point out of our answer choices gives me that point? So I'm going to kind of graph those other ones. So the first point we have is 4, 2. Well, 4, 2 is right here. That's nowhere close to where we're looking at in this is where we're trying to find a point. So we know that that's not going to work. Then we have 2, negative 8, which is way down here. That's not going to work. Then we have 11, negative 2. So 1, 2, so we have 11, negative 2, which is about right here. Pretty sure that's going to be our answer. And then we have 10, positive 2. So 10, positive 2 is R. They didn't ask us for R, they asked us for Q. So it's going to be 11, negative 2. All right, so for number 11, it says, what is the midpoint of the longest side of these vertices? All right, so I'm going to get some more graph paper here. And I'm going to make my grid. All right, so midpoint, so we're going to plot 1, 4. And then we're going to do 3, 4. And then 3, 6. 1, 4, 3, 4, and 3, 6. All right, so it asked me what is the midpoint of the longest side. Well, you should be able to determine that this diagonal side is the longest side. So they want to know the midpoint of that, okay? So when I'm looking at it and I graph it, I could pretty much tell that the midpoint is going to be at 2, 5, which is right here. However, how can I verify that? Well, remember, midpoint means you're going to add up your x's. So we're going to add up x1 plus x2 and divide by 2. Because remember, midpoint means the middle. So the way that we find the middle is we add up our values and divide by 2. And then our y's, we're going to add up our y's and divide those by 2. So this point we said was 1, 4. And this point was 3, 6. So if I add up my x's, so I have 1 plus 3 divided by 2. My y's, 4 plus 6 divided by 2. So 1 plus 3 divided by 2 right here. So that's going to be 4 divided by 2, which is 2. 4 plus 6 is 10 divided by 2 is 5, which is correct. So sometimes you can even see the answer just by graphing and not having to do the extra work. All right, now remember, parallel and perpendicular. So this is very important. I would write this down if you have notes. So parallel, remember, parallel lines have the same slope. And perpendicular lines are going to have opposite reciprocal slopes. So they have an equation and it passes through this point. So we have the point, we know it's perpendicular, and that's the equation that we're looking at. So the first thing I'm going to do is I'm going to write my perpendicular slope. Well, I know that the slope in the original problem. So my original slope is negative 1/3. So remember, the symbol for perpendicular is the upside down T. So my perpendicular slope is going to be the opposite. So it's going to be positive. And it's a reciprocal. Instead of 1/3, it's going to be 3/1 or just 3. So my slope is going to be 3x. This is going to be a drag and drop on your exam. You can easily drag and drop the pieces. Now we need to find the y-intercept. That was the piece that a lot of students struggle with. So how do we find the y-intercept? Well, you have your point and you have your perpendicular slope. So we're going to plug that into y equals mx plus b. All right, so I'm going to plug in my x. So I'm going to plug that in the x spot. I have my y. I'm going to plug that into the y spot. And I have my slope. I'm going to plug that into the slope spot. So this is going to be negative 10 equals positive 3 times 1 plus b, because we're solving for b. That's what we want to find, is that b value. All right, so this is going to be negative 10 equals 3 times 1 is 3 plus b. And then we're going to subtract 3 to solve. So b is going to equal negative 13. So we're going to bring the negative over and the 13 over. And there's my answer. All right, number 13, it says the midpoint of x and y is given by m. And then it tells me that one of my endpoints is x. So they're asking me for the other endpoint. So I have x and y, and I have the midpoint. So I know my midpoint is located at negative 12, 5. And I know that my x point is located at 3, negative 3. They want us to find the other endpoint y. So we're going to set up our midpoint formula. So remember, our midpoint formula is my x's added up divided by 2, and my y's added up divided by 2. Now, I know my midpoint for my x value is 12. So 12 equals the x's added up divided by 2. Well, I already know what one of my x's is. One of my x's is 3. So I'm going to take that out, and I'm going to substitute in 3 into my problem. And I'm going to solve this. So I'm going to start by multiplying the 2 over. So we get negative 24 equals 3 plus the second x. Or you can just call it x. It doesn't really matter. Then we're going to subtract 3. So I'm going to subtract 3, and I actually get x equals negative 27. Now, I think that the answer choice actually got cut off here, so I'm just going to write it over here to the side. It's probably on your paper. I probably corrected it when I gave it to you, but on mine it's still cut off. So then I need to do the y value. So when I look at my y value, I have a y value of my midpoint, that's 5. So I'm going to do 5 equals my y1 plus y2 divided by 2. Well, we know that my y value is negative 3. So I'm going to come over here and I'm going to substitute that y value in. So again, I'm going to solve this. I'm going to multiply and then add 3. And I get 13. So my y value is 13. And there's my other endpoint. All right, number 14, it says the triangle has the vertices at these 3 points. What is the perimeter? So remember, perimeter means you add up all the sides. Okay, so I'm going to add some graph paper here. And I'm going to make my coordinate plane. So I have the point 1, 3. I have 2, negative 3. And then I have the point negative 1, negative 1. So I have this triangle. Now, to find the perimeter, that means we're going to have to add up the sides. So I'm going to start with one of the sides, and we're going to do the Pythagorean theorem like we did earlier. So we're going to make that right triangle. So I have 1 unit and 6 units. So 1 squared plus 6 squared equals c squared. So 1 plus 36 equals c squared. 37, and take the square root. All right, so we're going to take the square root of 37, and we get 6.1. All right, now we're going to do the process again with another side. So we're going to make a right triangle again. So we have 2 units here, and 1, 2, 3, 4 units here. So 2 squared plus 4 squared equals c squared. So 4 plus 16, that's 20. Take the square root. So we'll take the square root of 20. And that's going to give me 4.47. So we'll say 4.5. All right, and finally, we have the third side. And we're going to make the right triangle for that one as well. All right, so we have 2 and 3. So we have 2 squared plus 3 squared equals c squared. So 4 plus 9 equals c squared. That's going to be 13. Take the square root. All right, so then the square root of 13, that's going to give me 3.6. So the perimeter, if we add up all of our pieces, so the first side we found was 6.1 plus 4.5 plus 3.6. So my perimeter all right, so for number 15, it says, which equation represents the line that is perpendicular to this graph and passes through this point? So we're actually going to do this one on Desmos this time, just so you can get some practice out of using Desmos if it's calculator active. So remember, to be perpendicular, that means it needs to intersect at a 90-degree angle. So what I'm going to do is I'm going to graph my original, and I'm going to graph my point. And when I look at this, I need to find a line that goes through that point and is perpendicular. So I'm going to start testing my answer options. So I have 4y equals negative 18. All right, so that does go through that point, and it does look like it's at a 90-degree angle. Now I'm going to change it to option B so you can see the difference here. We can see that it doesn't go through that point, nor is it at a 90-degree angle. So the answer for 15 is going to be A. All right, so then we have number 16. So number 16 says the vertices of the quadrilateral EFGH are given. What type of quadrilateral do I have? So you can graph this on your graph paper. I'm going to just go ahead and do this on Desmos just so that we can see all the points while I've got this screen pulled up. But again, you will have graph paper that you can graph it yourself. And 2, negative 6. Now, if I were to graph this, let me make sure I got all my points right. Oops, and that one is not, so I need to change that to a 6. So I can clearly see that this is a quadrilateral if I were to connect my points. I can see that it's definitely not a square because it's not going to have 4 equal sides. Well, then it's not going to be a rhombus because a rhombus doesn't have equal sides. A trapezoid has 1 pair of parallel sides, but we have 2 pairs. So this is going to be a rectangle that is not a square. Number 17. So I have a line that passes through these 2 points. Now, let me draw your attention to the fact that we don't know what one of the values is of the points. However, what we do know is that it's going to be perpendicular to this equation. So the first thing that we need to do is we need to solve for y. And the reason we need to solve for y is because we need to find the slope, okay? So I have 5y equals 4x, I have 5y plus 4x equals 8. So I'm going to subtract that 4x over. So 5y equals negative 4x plus 8. And I'm going to divide by 5. Now remember, when you simplify here, you're going to have to simplify both pieces. So y is going to equal negative 4 over 5x because those can't divide, and neither can the 8 and the 5, so plus 8 over 5. Now what I care about is I need the slope. So my regular slope is negative 4 over 5, but we don't want the regular slope. We want the perpendicular slope. So my perpendicular slope is going to change to positive 5 over 4. So here's what it's asking. What is that value of k? Well, if I have 2 points, I can use those 2 points and I can find the slope. So remember, my slope is going to be y2 minus y1 over x2 minus x1. So this is x1, y1, x2, y2. So I know my slope. My slope is 5 over 4. So my my y2 is negative 6 minus 4. And then this is going to be x2 is 3 minus k. Now, when I'm looking at this problem, I can see that this section, this piece right here is positive, but if I add up these two, this is going to be negative 10 over 3 minus k. All right, so for number 18, it says which choice passes through the point, and we have 12, 10, and is parallel to this particular problem. So it's going to have the same slope. So if it has the same slope, then my original slope is 3, so my parallel slope is also 3. So we're going to find the b in this problem, and we're going to find that by doing y equals mx plus b. Now, one thing I can do is go ahead and get rid of a and b, because we know the slope has to be just positive 3 and not the reciprocal. So we're going to take 12, and we're going to plug that into the x spot. We're going to take 10, plug that into the y spot, and take 3 and plug it in for m. So this is going to become 10 equals 3 times 12 plus b, because we're trying to find the b value. So we're going to do 10 equals, and 3 times 12 is going to be 36 plus b. Subtract 36, and b equals negative 26. So I have my parallel slope, which is 3x minus 26. Answer is D. I can also check this in Desmos, and I can plug in my values here. So I could say y equals 3x plus 6, and it has to go to the point 12, 10. Let me make sure I got those numbers right. And they want us to, we already decided it couldn't be the other, so we have y equals 3x minus 26. Now we can see that it goes. All right, so this is going to be 5 over 4 now equals negative 10 over 3 minus k. And I can cross multiply here. So when I cross multiply, this is going to be 5 times 3 minus k equals negative 40. And I'm just going to solve it out. So I have 15 minus 5k equals negative 40. And then I have net minus 15. So negative 5k equals negative 55. And divide by negative 5. So k is going to equal positive 11. So my answer would be A. Now, I'm going to go backwards for a second. If you need to review that, rewind it. But I'm going to go back for a second. I'm going to go all the way back to this original part that we just talked about. So when I look at this, I know my setup. I could easily test my answer choices to see which one works. So if I put 11 in there. So this is going to be negative 10. So I know that 3 minus 11 is going to give me negative 8. And negative 10 divided by negative 8 is positive 4 over 5, which is what we're looking for. Now let's say I tried one of the other answer options. So let's say I tried 2. So if I plug in 2 here, that's going to be negative 10. 3 minus 2 is going to be 1. Well, that's going to simplify to negative 10. That doesn't work. So if you can at least set it up, then you can easily plug in your answer options and try those out. All right, number 19, it says 2 segments are parallel. The first segment has these endpoints, and the second one has these. So what is the value of y? So it's very similar to the problem we did just a second ago. So we need to first find the slope. So in order to find the parallel slope, it'll have to be the same. So remember, this is x1, y1, x2, y2. So this is going to be y2 minus y1 over x2 minus x1. So it's going to be 9 minus 3, 1 minus 2. All right, so we have 9 minus 3 is going to give me 6. 1 minus, so that's going to be negative 1. So that's going to give me negative 6. So now I'm going to set up this next problem the same way, but this time I know that it should equal the parallel slope because the parallel slope is negative 6. So negative 6 is going to be y minus 4 divided by 3 minus 5. So negative 6 equals y minus 4 over negative 2. So I can test out my answer choices just like I did a second ago. So 34 minus 4, that's going to give me 30. 30 divided by negative 2, that is going to equal negative 15. So that doesn't work. All right, so then I try the next one. So 16. 16 minus 4 is going to give me 12. 12 divided by negative 2 does equal negative 6. So the answer is B. All right, number 20. Which equation represents the line that passes through this point? So, and it has to be perpendicular to this line. So the first thing I've got to do is I'm going to solve for y here. So we're going to do this one by hand, and then we'll check it in Desmos. So we're going to solve for y, so I'm going to subtract x. So 2y equals negative x plus 5. And then I'm going to divide by 2. Now, what I only really care about is the slope value here. So y equals negative 1/2 x. So my original slope is negative 1/2. My perpendicular slope is going to be positive 2. All right, so now we're going to take our point, because we need to find our b value. And we're going to do that by plugging it into y equals mx plus b. All right, so if I'm going to plug it into y equals mx plus b, I'm going to take my 4, plug it in for x. I'm going to take negative 5, plug it in for y, and 2, plug it in for m. So this is going to become negative 5 equals 2 times 4 plus b. So negative 5 equals 8. And then we're going to subtract 8, and we get b equals negative 13. So our equation is y equals 2x minus 13, but we can see our answer choices are not in standard form. But if I'm paying attention and I'm looking close, the answer is going to be D, because if I solve for y, it has the 13 in it. So we're going to subtract 2x. Negative y equals negative 2x plus 13. And then we've got to make sure we divide by negative 1. So that's going to give me positive 2x and negative 13, which is the correct answer. Now, we could plug this into Desmos as well, just like we see it. If it's calculator active, we're going to plug in the original equation and the original point, and we're going to test our options. So we have x minus 2y equals negative 14. We can see that that doesn't go through the point. All right, and then I'm going to do x plus 2y equals negative 6. That's parallel and goes through that point, but we don't want parallel. We want perpendicular. 2x plus y equals 2. Or excuse me, I think that actually equals 3. So it goes through the point, but it's not perpendicular. And then we have our final option. So we have 2x minus y equals 13. We can